Hey guys, so this week we are going to be revisiting paired data. So I encourage you to look at the plant transpiration video on how to make the parallel plots. Otherwise, this video is going to focus mostly on how to make the relative and normal change plots and the matched pair analysis. So over here, these first three columns are basically the average, four columns are the average heart rates you collected in lab and reported. So these are ready to go. You can do a matched pair on this. So on JMP, all you got to do, analyze, specialize modeling, matched pair, click it, and then you have to do these in pairs. So we'll do control to caffeine, bam, do that again, control to lidocaine, bam, and one last time, control to pseudoephedrine, bam. Um, and all you really need to focus on here is this probability greater than the magnitude of t. Uh, so in this case, for these sample data here, there's no significance here. These are all the same. Uh, don't worry about what this plot itself means. You can read the axes and interpret if you want to, but we really want to focus on the statistical test here, and then we'll rely on other tools to visualize this. So again, we could use the parallel plot. I'll just put this one in here quickly. Again, you'd have to do this per pair, but you can see how those look. So now we're going to go over quickly how to make one of the change plots, the bar graphs. So in JMP, like Excel, you can write formula. The difference is that you write them per column instead of per cell. So here I would take this column, I would make a new one, and I would tell it to make it a formula column. And then in here I can just click my formula. So I want to do final minus initial, so I'll do caffeine minus control. I'll hit apply, and it'll do that for all of these. All right, awesome. So I already did that for all of these. I named them D, so D caffeine, D lidocaine, D pseudoephedrine for difference, differential, delta. And then we can just plot these into Graph Builder. So we put these on our axis down here. Start over, we put these on our y-axis over here. And then we turn on some error bars. And unsurprisingly, those were not significantly different from 0. So that's one way you can visualize this. The other way is we can make these normal, so we can talk about the relative change. So we'll call that R caffeine, for instance. We'll apply that. We're going to make this into a, I don't know why it's doing that. There we go, the formula column. Edit formula. This is just a different way of doing it. We're going to make this our differential caffeine. We're going to divide that by our control condition. Apply, okay. And we can do that a few more times. So we can do lidocaine divided by control. Bam. Call that R lidocaine, R caffeine, and then last we'll do the R pseudoephedrine. Notice that it's not pseudoephedrine, in case you're tempted to call it that. Don't know why it likes to auto-click that. Do that divided by control. Badazam. Okay, and then we can once again plot these three. And unsurprisingly, it looks very similar to the other graph. So this is our relative If I bring up our absolute, you know, bam, bam. The this one gets a little tighter. The lidocaine in the relative, the pseudoephedrine gets a little tighter in the absolute. And that's it. So, good luck, guys.